Okay, so now let's use everything that we've learned about lists and how we can use lists as a stack or a queue and how we can use different loops that are in Python, and let's actually build a functional calculator. So we'll do an extended example here using this Jupyter Notebooks. All right, let's get started. So the calculator that we're actually going to build, if we go back to this, it actually uses something called reverse Polish notation, right? So that means it's not this typical kind of parentheses way that you enter things in. If you want to, say, add two numbers, you would enter the number, enter the second number, and then you would say plus. And the second that you hit plus, it would evaluate the addition of those past two numbers, right? If you wanted to multiply them, you would enter the first number, the second number, divide. And so that's it's actually a very quick and easy way of making a calculator and something that usually speeds up how quickly you can enter values into a calculator. So that's what we're going to do. So to do that, we're actually going to use a stack, right? We're just going to stack inputs. And so once we get an operator, well, that means that the past two numbers that we had, we need to do something with them: add, subtract, divide, multiply, whatever it might be. And at each instance of this, let's make the code more and more intuitive, more and more readable as we go on, okay? And so we'll ask for user input through some type of while loop and then build it from there. So the last example that we had basically looked very, very similar to this. None of this is going to change. We're still calculating, hey, is this a floating point number? And we're still calculating, okay, is it some type of operation or is it some type of float right here? But the only thing that we're going to add in this line of code is we're going to put this into a while loop. We'll say, hey, why the user input does not equal Q. While it does not equal Q, run this line of code that we have right here, or run these lines of code right here, where I'm going to grab new user input in the exact same way that we've done before. But then I'm actually going to append the user, whatever that value is that the user entered, into a list. And that list starts out as empty, but each time I go through this while loop, it potentially has something that's inserted into it, right? So let's just go ahead and run this code right here. So I'm now at the calculator prompt. So basically, what I'd want to do here is say for enter. And what I'd like to do is hit plus right here, and then have it go in and say, oh, well, 4 plus 4 is equal to 8, right? So, essentially, we'd like to set this up as a queue, right? But I'm not doing any error checking here also, so I could enter something like Eric, and it actually just throws that on the end of the queue right there, right, if it was Eric. So what we want to do here is actually, let's enter Q right here, so we want to quit, and that'll actually exit this while loop that we have right here, okay? Okay, so the next thing that we'll do here is let's add some functionality to this. Let's actually perform some of the operations that the user has entered, okay? So this stays, same as before. I have user input and I have my empty evaluation queue. And now I'm still going to, convert this over, if it's an operation, keep it an operation as a string. If it's a number, save it as a number inside this list, right? Now, if the length of my list, my evaluation queue, if that's ever greater than 3, right here, and the last operator is a plus or a minus or divide or multiply, if it's some type of operation, well, then I'm going to enter this if statement and do something with it, right? So the operation that I'm going to get here is I've got my eval_q.pop, right? So I'm going to pop off the element that I put off, the most recent element. So I'm going to pop off this from the stack, and I'm going to save it into result right here, right? So result is now plus, minus, divide, or multiply. And then I'm going to actually get the other two values that were part of this. So I'm going to pop these two off and get v2 and v1. And then I'm just going to go into a big conditional right here that tells me what I can do with the two numbers that I just popped off of that queue, right? So I'm assuming v2 and v1 are numbers, but basically if it's a minus, I'm going to subtract them. If it's a plus, I will add them. If it's a multiply, I'm going to multiply them. If it's divide, divide. And then what I will do is I will save the result that I have right here, and I will append it onto this eval queue that I have right here. Right? Now, if it wasn't minus plus, if it wasn't a minus, a plus, this or something, then it's going to append the operation back onto the list, right? But it'll have popped off these other v1 and v2. So that's not something we really wanted to do. But let's see what this actually does. Let's see if this works the way that we want to. If I enter 3, okay. Now each time it's printing off the queue. So if I enter 3, now it prints off. Okay, so my queue has 3 in it. Okay, great. So now if I say 2. Okay, now my queue is a 3 and a 2, and now if I hit, let's say I hit plus, so it adds the 3 and the 2 together, puts it back on the 5. We now have somewhat of a functional calculator. Now the problem enters here, what if I hit minus right here, right? It's gonna try and go on there, it's gonna add minus onto the queue. Now, what if I hit plus? It's gonna throw an error. And the reason it did that is because the second that it added plus onto the eval queue, it tried to dequeue 5 and it tried to dequeue minus and add them together, right? So it was trying to add a string and a float together. And so we get this unsupported types. I can't add a float and a string together. Okay, but for the most part, if the user is entering the information correctly, even though we're not doing much error checking, if they're doing something properly here, they're entering all the numbers, it still will work, right? So let's say I were to run this again. Where I entered 4, 4. I want to add these together, and then maybe I want to, 5, and I want to subtract 5. There's 3 right there, and then let me add 2 right here, and I'll multiply those together. 3 times 2 is 6, and so I can keep going with all of these operations until I hit Q. And if I've entered everything correctly, this works just fine as a very basic calculator, right? Okay, so this code is looking pretty nasty right here. Like this line right here where I have, the last value equaling to any of these, I'd really like that to be something a little cleaner. All right, so let's go in here and make this a little more intuitive, a little better. Let's define another function, which is operation, right? And so I'll put in the value right here, and if that value is a plus, minus, divide, or multiply, I'll return true, otherwise return false. It's not an operation that I support. And then the is float and convert user input, they stay the same. But I'm also going to define this, this new function called perform operation, right? In the previous code that we had, all of that was just sitting there in the main kind of function where it was like, oh, is this a subtraction, or what is it that we have right here? And so the way that I'm going to define perform operation is essentially, I'm going to give it the operation that I want it to perform as a string, which could be minus, plus, multiply, and divide. And I'm going to give it the values as a list right here, right? So values right here should be a list of length 2. So now when I actually do perform operation, I'm going to say, okay, vals of the 0 minus vals of the 1, or plus, or times, or divide them, right? And so now all I need to do to perform this operation is enter operation and vals. And that's really going to simplify the code that I have down here inside of my while loop, right? Because all I need to do now is I have this is operation function where I say, okay, add things to the evaluation queue. If there's an operation at the very end of the eval queue, well, set op. I'm going to pop off the elements, pop off the very last element and set that equal to result. And then I'm going to pop v1 and v2 exactly as we did before, right? I'm going to pop them, not do any error checking. I'm just going to pop these off, but I'm going to enter that as a tuple inside of my perform operation function. So I'll get v1 and v2, and I'll say, hey, perform whatever operation this is. And I know it's an operation because I checked to see if it was this operation. And then send v1 and v2 in as a tuple. Now, v1 and v2, I could have also inserted this as a new list, but if I look into my operations, I'm never actually changing val 0 and val 1, so I might as well enter this as a tuple or a list. It doesn't really matter. Python doesn't care, because this syntax will work whether vals is a tuple or vals is a list. So if I do this, I will get the result from perform operation, and I'll put it onto the queue. And so now it's the exact same functionality that we had before, but it's a lot cleaner syntax. So when I run this line, I can say, okay, 45 and 5. I'm going to add these together, 50. 50 and 10, right here. I'm going to divide them, and I'll get 5. Right? And so I can also enter Q, and now we've quit. Right? And so now this is really great. We're getting a calculator that's pretty functional. As long as we input the right things correctly, we have a functional calculator. And it's much more readable code that we have inside of this function. If it's an operation, get the values, and perform them. Right? Very, very intuitive and readable code. But we can do this even better. Let's make this more scalable. There's no reason that we only have to do operations that are addition, subtraction, multiplication, and division. We could actually have a list of operations that we can perform. And this makes it very scalable because now we're going to perform an operation which also might be, oh, take this to a power right here. And we'll use that with the caret operator I have right here. So I've got an operations list right here. And we're going to actually use this to make our code even more cleaner. So these are the operations that our calculator supports. So I'm going to redefine this isOperation function, and I'm going to have it say, hey, when I want to know if something is an operation, the only thing I need to know is that if that value is in operations list. Very readable code, return true, which means it's somewhere in this list. Otherwise, return false. And then the float and convert user input stay the same. My perform operation is basically staying the same, except I'm going to add one more else if statement right down here. And I will return values at the 0 to the power of values at the 1. Here. If none of those actually went through, I'm going to return just the operator. Okay, so now we come back down here and we have basically the exact same code that we had here before, right? The only thing is under the hood, perform operation and isOperation are just, it's a very scalable way of adding operations to the things that I have here and being able to check whether that's an operation that I have. So again, I can run this again. We can do 5 times 25, right? And so it's working exactly the way that we want to, and hit Q here and exit. What we've got here is something that's actually quite readable. And if we want to add operations to our calculator, it's as simple as adding them into the operations list that we have right here and adding some definition of how we can perform those operations. Now, again, this is not very robust code. It's very, very easy to break from the user standpoint, right? This code still, if I enter, 4, and then I enter 5, and then I enter minus, and then I enter minus again, I'm trying to pop an entry right here where the minus value, it tried to go and grab 2 values on the queue, but there was only 1. And so now I get a pop from an empty list error. I'm trying to pop off an empty stack that I have right here. So that's what we'll look at next time, is how to deal with errors and add a lot more robustness to our Python coding.